Hi, I'm DR.Vonk, and today's lab video is on passive filters. This video will not involve this guy, but it will very much involve this guy.
Hi, I'm Bryan. I'm Dan's partner, and this is going to be the best passive filter movie you've ever seen.
Amen to that.
Okay, so here's our circuit. We have a starting voltage that is alternating current with a frequency of 500 hertz and a amplitude of 1 volt. We also have a 1 microfarad capacitor over here, and that is followed by a 1K resistor. So if we look at our graph, the green line is our starting voltage, and as you can see, it's exactly what we'd expect. 1 volt is its peak, and phase is normal. And then the blue is in between our capacitor and our resistor, and as you can see, that is at about probably about 0.95 volts. We have lost a little bit of voltage, and then it looks like it probably around 15 to 20 degrees leading our starting voltage. Okay, so here's our second circuit. It is exactly the same as our first circuit, only we have switched around the resistor and the capacitor, so the resistor comes first. And as you can see, our starting voltage is also the green again, and it has stayed exactly the same. However, our blue has changed quite significantly. We are now at about 0.3 volts, so we have dropped dramatically. And our phase shift is 90 degrees lagging our starting voltage.
Okay, here's our circuit. Right here we have our power supply coming in, and those are coming through our function generator. They go down here. The voltage in comes over here, and then that goes through our 1K resistor, and then that goes into our 1 microfarad capacitor. And then you can also see that goes into this wire, which is also connected to ground, and that goes over into our DAC. So that measures V out. And then after it's done with our capacitor, it goes through the blue wire back to ground. And you can see there we have our green and yellow wire pair, and that is measuring our V in. So one of them is hot, one of them is on ground. So that shows our total voltage. And then finally we have our white and black wire, which comes over here, connects to these two, and that goes over to start. And this wire, this black and white wire pair here, goes to these two clamps, and that comes all the way over to our function generator, and that's what supplies it with our voltage. Okay, and here's our second circuit. Basically, it's the exact same thing, only we switch the capacitor and the resistor around. So instead of going through the resistor and then the capacitor, our charge is going through the capacitor and then the resistor.
Okay, so we just have the function generator in voltage-controlled output mode, and if we run the VI, the frequency should oscillate.
Sorry, did that ruin your video?
Nope.
Good. I mean, dang it.
And there we go. It's changing. And, amplitude stays the same, but yeah, that's changing. Also gotta have these two buttons pushed in. So here we have our VI, and it's pretty straightforward. We just have our DAC assist for generating data, and our DAC assist for taking data. And it will take the two wavy signals, the V out and the V in, and it will mess with their magnitude and phase. And it will spit it out into a Nyquist plot, aka a polar coordinates plot. And so let's see it in action. This is going to take a while, so I'm going to do a fast forward. And voila.
So as you can see here, this is when we're at very, very high frequencies. The magnitude is dropping down to almost 0. It's approaching 0, while our original amplitude is very close to 1. And then we have a phase shift of about almost exactly 90 degrees in the positive direction.
As you can tell, for one wave, when the first derivative is 0, the derivative of the other wave is at its highest, so 90 degrees out of phase. And here we have the plot of it going.
So right now we're only going to look at our high frequencies right here. and that shows that it's increasing, or it's approaching a negative 90-degree phase shift, and it's also approaching 0 volts for an amplitude. Now let's run it again and just immediately stop it. And here are very, very low frequencies. As you can see, they're almost the same amplitude, and they are almost exactly the same phase shift, and that is shown here on our Nyquist diagram. Okay, here's our second circuit, which features our resistor in front of our capacitor, and we're going to quick run this and then stop. You can see that at DC voltage we have almost exactly the same amplitude and phase as our input. You can see that up here we're approaching a gain of 1, and then we're also approaching a phase shift of 0. If we were to run it a lot more. So here, we're back. Okay, and now, as you can see, when we're at very, very high frequencies, our amplitude is approaching 0, and we're also in phase 90 degrees in front of our amplitude. Okay, so now that we're done fast forwarding, now that we're at extremely high frequencies, we can see that the amplitude is approaching 0, and that our phase shift is about 90 degrees in front, or plus 90 degrees. And then we're going to run one more time. I'm going to choose an intermediate point here. Right here sounds good. Let's change this. Okay, so now at our intermediate voltage or frequency, you can see that our voltage has risen, but it's not the same as our normal amplitude. And we can also see that it's about 45 degrees in front. And we can see that our original voltage is lagging 45 degrees behind. So now if we go up to our plot diagram, as you can see here on our plot diagram, at our low frequencies we're approaching a gain of 1 and a phase shift of 0. At our low frequencies we're approaching a gain of 0 with a phase shift of 0. And then at our intermediate point right here, we are in between 1 and 0 for a gain, and then we're at about a 45 degree phase shift. On our plot diagram here, as you can see, our low frequencies, we are approaching 1 with a phase shift of 0. At our high frequencies, we're approaching a gain of 0 with a phase shift of 90 degrees. And then here in the middle, we are approaching a gain in between 0 and 1 and approaching a 45 degree phase shift.
Quick, just in case, just to segment things. F9.
Don't hit flashing.
F9. Stop. Stop.